Let's go.
And then he was like, "Oh yeah, I did it all the time."
Good. So let's go here. So we're on 5.5. It's called the substitution rule. Now, do you guys remember something called the chain rule?
Yes.
Yes.
Okay, substitution rule is to undo the chain rule. We good? And if you guys remember, what was the chain rule about?
Reference.
I didn't hear what you said.
Outside of the
Uh-huh.
parentheses.
Yes, I do know that.
By the derivative of the inside of the parentheses.
Yeah.
And the derivative.
Awesome. The complete derivative. Yeah. So but the chain rule was if you have kind of layered functions, right? If you have layered functions, what you can do is you can take the outside function that says derivative, right? You move into the inside and inside, keep on taking derivatives of it. So the substitution rule says, what happens if I have something like that? What happens if I have a layered function that I have to undo? How does that work? And it's called a substitution.
The inside of the parentheses, then the end here would be outside.
Oof. Okay. Let's go. Let's go with it. Pretty close. So one example of this right here. So notice I have myself a complex or multi-layered process here. So I have a square root of 1 plus x squared. And the emphasis is really on this little piece right here, right? There's a square root symbol here, right? There's also 1 plus x squared, right? So almost you can almost think of 1 plus x squared as its own little function, is that right? And then the square root function is its own little function. Are we good?
Will there be a tissue box?
My
Yay. Let's see.
has been removed.
Okay.
Here, if you want to go
Just a little bit.
grab one from another class.
I'll wait. I'm too
Yeah.
scared to miss anything.
Okay, let's go. So, what is this? This is to see if you have layered functions that need a chain rule to undo, essentially. Okay, so let's jam. I'm going to go to the next slide. So here's what we're going to do. Since I put extra stuff on this side, I don't want to have it anymore. I'm going to jump to this. So I'm going to rewrite the problem here. We are doing this. Oh, real quick here. Is this a definite integral or indefinite integral?
Definitely.
Perfect. Okay, so the question is, how do we undo chain rule? Here's what we do. We do something called substitution, and we call this U substitution. It looks like this. You try to figure out what is the most inside function you have. And the most inside function I have is 1 plus x squared. You guys agree?
Yes.
Yep.
Sweet. What is the derivative? And that u value, that's just arbitrary variable. We good? Sometimes the other calculus books will use w. That's fine too, right? Sometimes, very rarely, they'll use a t as well, but it doesn't matter, right? What is the derivative of
plus x cubed over 3?
1, 2, x.
U, W, what about triple U?
There's that 1 through.
Hey,
Yeah,
what?
so first of all, du has to become a du at this point, right? Because you're taking the derivative. And we're going to take the derivative with respect to x on one side, with respect to u on the other. So derivative of 1 plus x squared is?
Is it 2x?
2x is good. Remember, for derivatives, right? Because we're doing derivatives in our mind. So now you guys have to do derivatives and antiderivatives in the same
Wait, we find
space.
the derivative first?
Yep, you got to find the derivative first.
I like how you find.
It's our safe spot for me at the
Like
moment.
adding a moment. Like I don't know what.
Okay, gotcha. Uh-huh. Oh, that's so cool. Good.
Question, who's responsible for making these?
Oh, boy. A few people here. The Bernoulli brothers.
They sound criminal.
Let's see. Leibniz gave us notation, and Newton gave us the concepts to sort of think through. Okay.
So
again,
if I go back,
Bernoulli brothers gave us limits and kind of like a really understanding of limits.
Didn't they solve? Didn't they prove L'Hopital's?
Yeah. The extended L'Hopital's. Yeah. Okay, class. Real quick. So notice what.
correct.
Because it wasn't.
Here's I'm going to move things around. Let's see if this makes sense. So if I move things around, I'm going to move the 2x towards the end. Notice there's a 2x dx right over here. I'm going to move that to the end.
Think of how many diseases would exist if we went back a few years.
So here's what I'm going to do. I'm going to move the square root of 1 plus x squared in front. And I like to have all that stuff at the end. We good there? And this is why we call it substitution. So here it is. We're going to substitute a u in for 1 plus x squared. And then we're going to substitute a du for 2x dx. Perfect. So if I do that, does this become a lot more simpler problem to solve? Yeah. So now notice instead of kind of like two different functions or a product between two functions, now I just have a single function called u to the square root of u. Okay. Help me out here. This guy is technically to the 1/2 power, is that right? This is where the fun begins. If I change forms, because I don't like to have radicals in there. If I want, I'm going to change this up to the 1/2 power. And then can you guys give me the antiderivative of u to the 1/2?
You know, going backwards is,
Like,
Begin.
it would be.
Right,
are we
gotta
finding
add.
the derivative of the antiderivative?
Antiderivative.
Antiderivative.
3/2, right? So 1/2 plus another one. 3/2.
Would that?
2/3 u to the 3/2.
All right, let's go with it here. So what we're going to do is we have to add 1 to the 1/2, right? Technically, you're adding 2/2, which makes 3/2. Are you okay there?
Mhm.
And then we have to put this in the denominator. So there's my 3/2, but we don't like to write it that way. We have a much more easier way of doing it. All we do is we flip the 3/2 into 2/3, right? There's my 3/2, and we flip the value around. Almost done, guys. So now notice our answers in terms of u, and that's not what we originally started off with. We started off with,
dx.
yeah, x's, right? So what we're going to do is we're going to back substitute what we originally substituted. So this guy here, can you back substitute the end? So we're going to rewrite it exactly the way it was, except in place of u, we got ourselves a 1 plus x squared. So final answer. 1 plus x squared to the power of 3/2 over 3 plus c. Are we good there? There is the
Do
antiderivative.
you have to break it down? Or
No, leave it just like that. It's just fine. I do want to show you just real quickly here.
There's no like for the chain rule, there was like a formula kind of that you would follow. Is there like a formula?
No, the fun part here is you almost have to guess. Go.
You know, see if there's
Yep.
a tissue box.
Perfect. Yep.
Somewhere.
I'll stall.
All right, I'm gonna do it.
Wait, so,
No. So just go ahead. Good.
so the area under the function, the original function from 0 to x is equal to that.
No, you're talking about the first part of fundamental theorem of calculus 1.
Yeah.
If that was the case, it would be the original function that's inside the integrand, right? Not this one. Oh, so yes, the area underneath it. Yes, that's correct. Yeah. I was thinking you were doing the derivative of. Okay, real quick here. Just out of curiosity here. Notice how this works out. If this was, I'm going to go backwards now. Ready? If I were to take the derivative, let's say I go back all the way to chapter 3. I say, I want to take the derivative of this. I want to know whether this is going to give me the exact value that I had before. And you guys just don't need to write it down, but just think with me here. Now, this is chain rule in our hands, right? What would you do with chain rule right here?
I would take the inside bit of the function, then I would.
Outside first, though, right? You would take the derivative of the outside.
Like 3 times 2 is 6.
Yes.
So that is 6 in parentheses. Square root of 1 plus x squared power.
Careful here. The power is not 3. The power is 3/2.
What?
Right? Because that little square root in there.
Oh, all right.
True. So you're going to do what? Yeah. You're going to take the power of 3/2 and you stick it out in. You're going to put it out in front. Is that right?
Yep.
So you're going to put it out in front, which is 3/2. Everybody agreed there? You're multiplying times what was inside there. You're going to subtract 1 from 3/2. Does that give you 1/2 over 3? And then what else are you going to do here?
You would add.
And the derivative of c is 0, is that right?
Yes.
So we're going to multiply by what?
The inside,
Mhm.
the inside, which would be about 2x.
Perfect, 2x. So notice after you do the cleanup over here, the 3's are gone, the 2's are gone. And notice what we have is, we have exactly what we started with in the beginning. Again, there's your, again. All right, is that what we started with? So this is undoing the chain rule, essentially. That's what we're doing.
They're right there.
The derivative of 1 plus x squared.
Oh, right.
Like good idea, and this tangent.
Mhm.
What if you moved to Washington and then taught all my math classes at Spokane and like, I think that's a really good idea. Then you can be my teacher throughout college too.
It is a possibility,
I think that's
but it is a very, very low probability.
Saying calculus when you teach it. I think that's a really good idea. Yeah, I think that's a great idea, and you'll love Washington.
Oh, I'm sure. Yeah, I've been to
Cold, wet,
like
miserable.
Gonzaga is just
Yeah, they're
really pretty.
hmm
So, and then I'll be there, and you'll like get a teacher certificate.
Of course,
They're gonna be like so happy to be there.
I will think about it.
Yeah.
All right, let me give you guys the formula.
Who's gonna ditch on Monday?
Senior ditch day.
When you need ditch, then maybe he would do it.
If I didn't ditch
Uh-huh.
on Monday, would you promise to?
I will promise to think about it.
Or a total of 5 seconds.
That's such a bad answer.
Yeah.
Like a crash bandicoot.
What?
No, that answer is
Oh, it looks
ask
like
your
a
mom,
crash
and then
bandicoot.
the mom says ask your dad, and then you're just going back to it. That's the mistake.
That's so funny. Okay, class, here we go.
It's a cool fact.
Here's what according to formula, this is what we're trying to undo right here. We are trying to undo a function.
Okay.
Whoa, go back. So if u is the same thing as g of x, and we know that is differentiable, right, on some interval. We're trying to connect this g of x with its derivative somehow. So the derivative of g of x, we can substitute its derivative and the dx as a du. That's essentially what we're trying to do.
Wait, so it only works if it follows this.
What do you think?
Yes, yeah.
So there's
awesome
no
X pro at.
Yeah, in fact, second semester calculus, you spend a whole entire semester trying to figure out the 112 rules.
100 now?
112 rules to undo antiderivatives. Blush, blush.
You just killed Eli with that.
I know, yeah.
See, this is why Gonzaga. Like this is the whole point. Why?
Imagine having to scroll through that list as a Sam.
So too.
Mhm.
I'm already
Right, formula.
thinking I'm going to.
Oh, it's gonna be so easy
F.
because you're gonna see it for the second time around, and you're gonna say this is so
Starts in
easy.
2 years. It's like,
In fact, what we do in this class, we do a semester and a third of a college class. We do more in this class than we do at college first semester.
Except for if you get.
oh, so we're doing like. Oh, I see. What?
Yeah, so-
this is all second semester.
Antiderivatives, we're going to see a little bit of it, and that's it. We stop there. So we go a little further. And then we also, most universities don't do the e to the x derivatives and hyperbolic derivatives. They don't even do those the first semester. They wait for second semester to do those. So you guys, yeah, essentially, I looked at Cal Poly, their quarter system. We do a quarter and a half here. And then you guys, and then whoever, if you do calculus there, you're going to do this in your first quarter. So you guys be in good shape. Like all the alumni that have come talk to me, they pretty much said the same thing. I saw it already before, see it for the second time. It was like, oh, I know this stuff.
I think I know this stuff.
Think I know this stuff, yeah. But you'll be doing great. So, all right, let's try some problems. Here it is again.
Basically,
The substitution rule. Here it is. Can you guys find this right here? I need the antiderivative of x squared cosine of x to the fourth plus 2 dx. All right, and if you got it, try it yourself, go for it. If you think you need a little tiny bit of help, That's fine. We'll work it out.
I missed this. I was confused on the formula. Could we swap back that, please?
On which one? The formula?
Yes.
Yep. Go back to the formula just real quick here. Those that let you write this down first. There's a little tiny bit of a trick here, right? I'll let you kind of work with that trick just for a little bit. Okay, but let me go back to this one.
Give him a long look.
Okay. Okay.
Because he's like
Okay.
saying words right now. I'm just gonna look.
I wonder if it goes forward. Oh, it does go forward. Okay.
What?
Okay.
Same.
All right. So the question is this: what is the inside function?
X fourth.
Perfecto. X to the fourth plus. So that was going to be our u function. U function is x to the fourth plus 2. What is the derivative of u and x to the fourth plus 2?
4x third. 4x cubed.
Perfect. du is equal to 4x cubed. And that's it, because the 2 goes to a 0.
1/4 cosine x.
Perfect. Okay, so the book does it a different way than I do it over here. I'll teach you my way because I think it just makes more sense. So question is this, all the way out in front, before the antiderivative symbol, what is there? What number is there already sitting?
Third.
Like right over here. What number always sits? Nope.
Beyond thing.
Nope. It's a 1. Perfect. There's always a little 1 right next to everything, right? Can you make that 1 into like a 12 over 12?
Yes.
15 over 15?
Yes.
-3 over -3? All right, what we want to do is we want to make it as a 4 over 4. How come?
We can get it inside.
We can get it inside. Okay, so I make that 1 into a 4 over 4. The reason for it is because I need a 4x cubed at the end of this thing. We're good there.
We're solving for antiderivative.
We're trying to do the antiderivative.
Did we just solve for the derivative? X forward?
So we have to take the derivative of u, right? Because we're going to switch our variables into what we want to do. So remember, x to the third, cosine x to the fourth plus 2, that is a very complex function, right? We're trying to make it into a small function. So here's what we're going to do. Remember how we can move constants in and out?
Mhm.
At the end of the day, what I want is I want a 4x cubed dx at the end. Cool. So here it is. Antiderivative is a 1/4 in front. And I'm going to move the cosine to the front. Cosine goes to the front. And then I'm going to move that 4. And I like to put a little multiplication symbol right over here because it kind of separates the whole thing. We good there? Does that make sense?
Mhm.
Cool. Okay, now can we do our substitution step?
Almost.
Yeah, the 1/4 stays in front.
Does that say multiply or equals at the end?
This is multiply right here,
Got it.
but that's an equal over here. All right, so all I did is I just moved the 4. All right, I pushed the 4 in as a constant.
Now we can
So I think we're ready. Yep.
X to the 4.
Can you guys substitute the u as well as the du now? And what does that look like? It's going to be cosine of u du. Are we good? Is that something that we can do now? Absolutely. What is the antiderivative of cosine of u?
Sine u.
Perfect. So this becomes 1/4 sine of u plus c, right? Because we have an indefinite interval on our hands. Okay. Notice how that made it to be an easy function at this point. Okay. All we got to do now is what? Anybody?
I have a quick question.
Uh-huh.
How did we get from the 4/4 to the 1/4 again?
We slid the top 4, the numerator 4. We moved it all the way to the end. So then we have a 4x cubed
Got it. Okay.
dx. We needed x to 4 there. Okay. One last step. What do we have to do?
Plug in the original thing you
Yep, plug in the original x again. So 1/4 sine of was the original u.
4x squared or x squared plus 4 x to the fourth plus 2.
Perfect. Okay, yep. Plus c. So we back substitute the x in, and we are done.
Okay.
Okay, we good?
Mhm.
Question. Do you guys want to see the derivative of it?
What do you mean?
No.
If we take the derivative of this one, it should match back to the original function we started with, right?
I'll take your word for it.
Okay. Okay, good. The only trick here is that little substitution step. And you guys okay with that substitution step from x to u? Second? Okay, next problem. Here we go.
It seems manageable-ish.
I think so.
It's just you have to make sure you do everything in the right order.
Uh-huh. It's just a process. So all yours here from beginning to end by yourself if you can. Ask me questions if you need it. But very similar to the first one that we did. And give you guys about a minute. Try it yourself, minute or two, try it yourself.
A quick question.
Uh-huh.
What is the answer or what is the implication of finding antiderivative? And what would that represent in the per thing? Just the area?
Area, uh-huh. Area going down to the x-axis or going up to the x-axis, depending where you're at in the graph.
And this is only for indefinite. No, yeah, indefinite.
So indefinite because of a little c value, right? It's all the different possibilities, right, of it, right? Because the c is going to change. And remember the function, well, and interestingly enough, Eli, real quick, the function that's formed is the amount of area you have underneath the original curve, right? That's the function that we get. All right, guys, real quick here. What is my u substitution?
1 plus
1 plus x squared is good. We know the derivative is d. Ooh, I did a whole bunch of stuff here already here. Let's see. So yeah, u, I got them in different order here. So 1 plus x squared is the d. That means du is 2x dx. Is that right? I don't know why I did it over there. Okay, so then what I'm looking at, the original problem, I have an x over here. I have a dx. I'm missing a 2. So then I'm going to make a 2 over 2 in the front of it. Okay, you guys talk to me. Are you guys okay so far?
Just one.
So this part right here should have been the first part. Then I noticed you need a little 2 in here. I don't have a 2 originally. Therefore, I'm going to make a 2 over 2 out in front. All right, let's slide stuff in. So how about a 1/2 in front? The function that I want, I'm going to convert, and then my little dot. I like my little dot because it just separates the whole thing.
ACDC got it because one of those electricians up there. I don't know about this new technology. Ultimately curse boost a DC current. For those AC to DC. Cool. Of course, with elaborate Scottish accents. Yeah, yeah. And then in Scottish nature, they're when drinking or talking about this over a drink and go, be a great name for Rockland.
Yeah, we're the two different types of electricity. Let's go.
No, it was a very horrible discussion. Because I was like, no, I don't want to.
Okay, so are we good there? So notice for a few of these here, notice we get that square root a lot. Right? It's just much easier to see what is the inside function based upon that.
I'd like to start a notion to start referring to square roots as screws. It just sounds a lot
That should
more
be your
whimsical.
senior project.
Just no, I should have had that would be so funny. It's like I'll propose for my project.
I wrote a 24-page research paper explaining in depth why square root should be called roots. That's what you said.
Okay, are we good there? And then let's do the antiderivative. You guys can? You guys finish off the problem.
No, that'd be so funny. End it with I was wrong.
I'll research subject. I was wrong.
This was an entirely worthless endeavor, and I'm going to get a horrible grade on this assignment. Thank you very much. Thank you for listening to my TED Talk. No, just do a word for word recreation of the why every Star Wars movie got named wrong. Have you seen that?
Mm.
Anyone see that?
No.
Oh my gosh, it's okay.
How many pages is paper?
Mine is 12.
It's
Then
yeah,
Jade is
somewhere
like
around like 12.
Mine's gonna be like 17.
It's supposed to be like
I'm 4 pages
anything
in.
above 10.
Jaden wrote 32 pages.
That's disgusting.
Insane.
Yeah. History, oral history.
And what font?
And at times in Roman 12.1.
What?
Will Dimba. 20 pages worth.
Can we point out that you said
Yeah,
times
Dr.
0?
Yeah. What's the max? And Dr. Ocean was like 9, and Will said mine's 20, and Dr. Ocean.
What is his on?
What did you write it about?
The Vietnam War.
There's like so much. Only 20?
Yeah, that's what I was thinking.
Everyone's just mind. What?
I can do it in one page.
All right, can you guys finish it off? Did you guys finish it off? Are you guys done? Something about the one u to the 1/2. We've done that before.
What's the ratio of
Two
times
thirds
that you're like
to 3 halves.
annoyed by our talking to like you find us funny? Like, what's the ratio?
Compared to the
Like, are we like too annoying, or are we like just right, or are we like funny? If you like one bar side conversations.
I'm annoyed constantly.
Sorry, Avery.
No, I'm stuck.
No, I'm good with you guys here. Yeah, we're still talking.
They talk too much.
They don't talk too much, but at the same time, if it's a bigger class, I manage it differently too, right? It's like it's go go go, right? As opposed to if it's just us, it's a lot more just relaxed. So the more students, the more I feel like I'm more like, okay, go go go. All right, are you guys done yet?
Yeah.
Let's go. So we have ourselves the 1/2 out in front, the u goes to the 3/2, and then we also would just reciprocate, right, to the value itself. Right, so the 3/2 should be on the bottom, right? But because it's a fraction, what we do is we just take the reciprocal of it, move the 2 out to the front. So if you're okay with that.
Please cancel.
And the 2s are gone. Yep, 2's canceled.
I thought it was supposed to be negative 1/2.
No, because you're taking the derivative at that point. You take the antiderivative by adding a 1.
Oh,
Look up this concept on YouTube, or whatever. Look up this.
Uh-huh. Yeah, it just could put, calculus substitution rule. If you want to just put basic substitution rule, because there are multiple substitution rules. Second semester. So we have learned we have 15 rules so far, is that right? Antiderivative 15 rules? When I was in school, there was 81 rules total. When I got out of school, there came to be 112 rules.
I keep doing my
There's
project.
just
More
become
stuff to add to my project.
Yeah, see, interesting. Knowledge keeps on growing. We find out as math grows, we should teach this in this. We should teach it in Calc 2, and kind of things come down the list.
See,
Anyways,
we're learning
okay.
stuff that took people hundreds of years and several degrees that we don't have the energy to get. And that's good for us.
Mm-hmm. Progress.
Like
And biology
think of it,
science
like
can-
biology classes in a few hundred years are gonna have DNA splicing in the lab. So, I mean,
What's that?
That'd be interesting, yeah.
and then,
Then-
okay, today, kids, we are
Uh-huh.
gonna make a hybrid between cats
It's
and
senior
rats.
project weekend. We are all very stressed. If two are on class,
I'm
I think
joking.
we deserve some grace.
That's interesting too. And then usually the lag is about 50 years behind by the time it goes from what's happening now to actually get back into the schools and teaching in the classroom.
The world might be gone in 50 years.
That's actually a good investment. Like it's a bet. It's like, all right, I bet you the world will be gone in 50 years, several millions of dollars. Either you don't have to pay it,
Trying to switch.
or
I'm so sorry.
That's a bad investment. Because if it's gone, you do have to. You don't get the money.
I meant the other side of it.
So
And there's that.
proud of her.
What about
As a
Spanish?
teacher, I tell you, don't do.
Yeah, especially in calculus class.
Oh, baby Lucy's all grown up now. She's off to college.
That's cool. So real quick here, you guys can.
Yeah.
This is a correct answer. It is called rational exponents answer. We good? Because you have a rational, you have a function or a fraction in the exponent. You can write it like this. You can write it like this. Sometimes the book will write it. This is called radical form right here. So rational exponent. This is called rational exponent form. This is called radical form.
Have you
So
tried assassinating them?
It's a free radical.
We don't like those.
Remember the physics, That's what we're doing.
Mr. Hondo, do you want to know something really sad I found out yesterday? Yeah. I thought Ohio was where Idaho was, and Idaho was where Ohio was. And Lucy's going to school in Ohio, and I was like, I'm gonna be in Washington, and then it's a 30-minute drive to Idaho, where I thought was Ohio was. So I was all excited. I was like, oh my gosh, like, if I ever miss Lucy, I could just like drive.
I love how you say that. It's like
2 hours so I can
yeah.
go see her.
Well,
Yeah, and then I found out that it's
the
not.
Midwest, but it's
It's
not
a
True,
one,
true.
It's a 1 day and 7 hours.
Ohio is mid-east. That's
why is it taking so long?
Ohio has the third largest population of Amish people. Indiana's second.
What? Passing Montana. Hold on, I thought it was before.
I thought it was 1 hour, not 1 day.
Wait, didn't
I thought that as well too, because my friend used to live in Ohio, and my sister lives in Idaho. So like, oh, you guys live close to each other.
Mid-East and the Midwest.
Completely different. I thought, because for some reason I always think that like Utah and Idaho and Ohio, they all sound similar and they're all like near each other. Well, at least Utah and Idaho are, like,
Georgia and Georgia are pretty similar sounding.
Yeah.
They're different places.
Yeah. 2 different continents.
Yep. 3 different continents.
anyway, it was very devastating.
Yep.
Georgia and Georgia?
Lucy's farm.
Georgia is in separates between Asia and
Oh,
Europe.
3 different. Gotcha. Okay, that's true.
originally I was just saying that because there's 3 continents in between, and I was like, oh shoot, no, I'm right.
All right, class. This one maybe is a little bit of a tough one. Let's go for it. A little bit of a tough one. A lot of things happening here. So, whoosh, let's go for it. So, question.
Quotient roll.
I just wish there was such thing as a quotient.
You're only in 112 rules. There's 1 inverse quotient roll.
Maybe there.
13.
So let's go with it. So, what do you think is the inmost function?
1 minus 4x squared.
I think so too. I'm going to go with that one here. So 1 minus 4x squared.
8.
Close.
Negative 8n.
Thank you. Negative 8x dx. So now the question is, what can you move around, or what should you have in front to produce what you need out of it?
Move the x to the dx.
What 1 do we need to be in front?
8 over 8.
There you go.
Negative 8 over negative.
We need a negative 8 over negative 8. Are we okay there? Because here's a good question. You put. So notice you have x over here. X is here. Dx is here. Dx is here. This has a negative 8 in here. And then whenever we are at numbers, there's always a 1 in front of everything, right? You can always multiply stuff by 1. So there's technically a 1 sitting here as a multiplier. So then the question is, what can I make this 1 into? So that means I can have a negative 8 inside my function. and it'll be -8 over -8 because -8 divided by -8 is still 1. So I have not multiplied anything in the sense into it. Good there? Okay. Let's move things around. Let's see what we got here. So we have x over here on top, 1 plus or 1 minus 4x squared dx. Okay, now let's move stuff. What I want to keep out in front is a -1/8. What I want to move into it is going to be a 1 over square root of 1 minus 4. My little dot. We're good? -8x dx. And then, yeah, once I get into this form, and if you want to, some people can skip this step, go directly to u because they can kind of move things around real quick here in their minds. I wonder who I'm referring to. And then we go -1/8. Oh, we have a square root. Now it's on the bottom of a fraction. Interesting.
Do we do it again?
No, the question is, do I know how to take an antiderivative of 1 over the square root of u?
Yes.
If you're definitely like one of those people that
Natural
are in
law
Hot
of
Tropical.
Ooh, no, I don't think so.
Hot Tropical.
How about this?
That sounds
If
so
you
familiar.
take this,
Into it, but that sounds really familiar.
Oh, you can make break it out of radical.
oh, cool, into.
Get negative, u raised to the negative 2, 1 over 2, -1 over 2.
Yeah, so remember the square root,
Negative.
the square root is a 1/2, is that right?
Mhm.
But if it's on the bottom, in the denominator, it becomes a -1/2. Now the question is, can I take the antiderivative of u to the -1/2? Yes. I add 1 to the exponent, right?
-1/2.
And I
gives
flip it over.
So it's 1 over 2. -1 over 2 squared u.
So -1/8 out in front, and here's my u. -1/2 plus 1 makes a positive 1/2. Is that right? And then we take the 1/2 down to the bottom, except we take the reciprocal of it since it's just easier to do that real quick here right in front. And then we have ourselves a plus c at the end. What can I reduce?
The 8 and 2.
I'm not going to move this out here just so. Let's see if it goes. Oh, yes, there it is. It goes above the screen. That's nice. Okay, are we good there? Oh, yes. Can we back substitute everything in now?
Yeah.
Yeah.
I remember what I was saying yesterday. Hey, yes, there's too many intelligible words for Simon.
It's the today.
So the 2 and the 8, because that be reduced? How about a 4 and a 1? I still have a negative out in front. And then the u now becomes 1 minus 4x squared. So how about final answer? Tell me if we went too fast. Let's see. Oh, that's why I'm actually not on the slide then. Those guys are gone. And I got myself -1/4. Square root of 1 minus 4x squared plus c. All right, that is an appropriate way of writing it. That's no problem. This guy is another way of writing it, and that is no problem either. So 2 different answers, which are totally correct here. So I got two more problems to go. 10 minutes to get there. We'll get there. Okay, next one. A little different, but I think you guys can do this yourself. We good? So try it. I need to take the antiderivative of that. E to the 5x. This should be pretty easy. And then we'll do the tricky one after this.
Yes, the
Really?
were not even trivial.
And just notice that it's all the same process, right? It's all the same process, right? You get a u, you take a derivative, you move things around so that you get what you need out of it, put a dot to separate it out, and substitute. I'll give you guys a minute. Try it yourself, see if you guys can see what you guys can do in a minute, or just wait for me.
I do be tempted. Could I get the hint of which the innermost function is? Would be 5x.
Yeah, it's 5x. The inside function is 5x, right? Because it's e to the 5x. So we'll go with it together. Those that are waiting for me here. That's my u function. So think about what is your du. 5 dx. Okay there. So problem is we don't have a 5 there. We just have a dx. That's it.
So we'd make a
5 over 5. And again, I'm writing all the different steps. You can skip a step or a few here in this point. Okay, I made my 5 over 5.
Sure, I know exactly what it is.
Or don't skip a step. So then I'm going to slide my 5 in. And I want to make a 5 dx. That's my whole point. Making a 5 dx. So I have myself my 1/5 and antiderivative e to the 5x with my little dot. And everything past the dot better turn into a du at this point, right? 5 got slid in, and I have a dx at the end over there. All right, and then let's substitute for u.
So EU.
E to the u power, du, right? What is the antiderivative e to the u?
E to the U.
E to the u. E is its own antiderivative. E is its own derivative. So I got 1/5 e to the u plus c. And all we got to do now is, I'm running out of room, we just have to backfill in whatever the u substitution was in the first place. 5x. So final answer in the top right-hand corner. Answer is 5 on the bottom, e to the 5x on top plus c. Are we good there? That looks pretty okay.
Answers up top.
Up on top, yeah.
Since
Cool.
Awesome.
Who's senior projects in CH6?
None. I'm doing college tonight, but I'll be here tomorrow. And I am Sebastian's senior project. What was it called? Senior project what? Advisor. There you go.
Teachers watch
So
single, like, well, the ones that every single session. I think so. Right?
again, yeah, I usually stay for all of them, and then I'll, yeah, just couldn't and commit to it.
I'm gonna
It's
try.
fine.
I want to go.
Mm-hmm.
Still.
Now, are you guys? Who's presenting today? You're presenting today. You guys are all presenting tomorrow, then? Okay, gotcha.
I'm still on the rocks.
Gotcha. Okay. Yeah, it's good to see in action, I guess, a little bit. Okay, guys, one last one, and this is the toughie. Not gonna lie to you. Here it is. Here's what we got.
Mr. Honest.
So notice something does not make sense here. Something's really not
I know.
making sense.
the entire thing.
The entire thing. So we have something that's caught inside.
Mhm.
We call it nested functions, right?
Mm.
It's the 1 plus x squared. But then we also have that little x to the 5th on the other side.
Chain rule.
And so, not yet. Because remember, the whole point of all this is to undo the chain rule, right?
Reverse.
So let's go with reverse kind of ish chain rule. Here it is. I'm still going to have u as 1 plus x squared.
And then we're gonna have U1 and DU1.
Du is going to be 2x dx. No problem there. So far, so good. So here's our little problem. There's no way I can get a 2x dx out of x to the 5th dx.
Mhm.
But if I kind of just separate stuff out, let's see. How about this? This is the tough part. I know I need a 2 in there. Is that right? So 2 over 2 is good? I'm going to slide the 2 in. At least, but then I have extra x's. Is that true? I have extra x's on my hands. So here's what I'm going to do. The trick of the trade here. I'm going to solve. Remember how I substituted for u?
Mhm.
I'm going to solve it for x. What do I need to do?
So for
I'm going to subtract 1 from both sides. Is that right? u is equal to 1 plus x squared. If I subtract 1 right over here, subtract 1, will I be solved for x squared?
Yes.
Probably.
Yeah. U minus 1 is equal to x squared. So now I have a little connection between u and x, right? In this case, u and x squared. Okay, let's see. How am I going to do this here? Let's see. So then I think to myself, this one. This is going to be the tough one. This is like the last two on the homework. So isn't x to the fifth really just x to the fourth times x? Good there? So that means I have my x. I have my 2 already. It's right over here on the outside. But I have this extra x to the fourth. So I'm going to do this here. If I square both sides, does that give me x to the fourth?
Mhm.
So notice all I'm just doing, I'm just trying to coordinate the pieces together. As long as I have the pieces coordinated, and then what I do is I'm just going to multiply it out. U minus 1 to the second power. Isn't that u squared minus t 2u plus 1? Is that equal to x to the fourth? Okay, here's my coordination now. Whew. Again, a little tough one. So 2 over 2, square root of all that, and I'm still left with x dx. Tell me if you guys are okay with it. I don't like the way I wrote it like that. Sorry, guys, real quick. Can I back up just a little bit here?
My confusion is
Yeah.
immense.
Let me back up just a little bit. Let me rewrite it the way I wanted to write it. Where's my pen? Okay, so let's see if we lined up everything here. So this is going to be the square root of 1 plus x squared dot, because I'm separating that out. This will be x to the fourth dot dx. Okay, is everybody okay separating all those pieces out? Got that piece out. I got the fourth, and I got this almost I got the 2. So I just need to do this one here. So I'm now going to go 1/2 antiderivative 1 plus x squared. Watching time here, dot x to the fourth dot 2x dx. Are we okay with that right there? Then we got the substitution step. Substitution step is 1/2 still. Antiderivative, the square root of u multiplying u squared minus 2u plus 1 du. Whoa, are we okay there?
Is it negative 1/2 in front, or just raise 1/2?
Just a regular 1/2. Okay, guys, real quick, is that a crazy one? All right, do we see all the pieces though? All right, you just had to do a little bit of thinking about right over here, a little bit of thinking because there was no way to get an x to the fifth out of this. So we separate that out in order to accommodate the x to the fourth, solve it for the x value, and then we try to kind of mesh the x value so that it can kind of be substituted in anyways. All right, so then I think we're ready. Let's go with distributing the, oh, hold on. We have a product between the two of them, right? So real quick here, if I were to multiply this into this, what do I get? What is u to the 1/2 and u to the 2 going to make as you multiply them together? Isn't u square root of u isn't u to the 1/2? Is that right? Square root of u is u to the 1/2. So what is u to the 1/2 times u to the 2?
U.
Which one's really close? No.
Close.
U. Square root.
I'm gonna go
2.
5/2. Is that right?
Oh, it's addition.
Right. It's addition between. Right. Uh-huh. Okay. So then the question is this. Almost done, guys. Minus 2. Go to that. What is square root of u or u to the 1/2 times u? Yeah, we're past time here, guys, already here. 3/2 plus the square root of u times 1 will just be u to the 1/2 du. Are we good there?
I'm going full battlefield right now. No idea why, but.
We're good there.
Nothing but fun.
So we're going to have to undo, right? So those are all power rules now. So you guys, what is u to the 5/2? And you take the antiderivative of that.
5 halves. 5 times U.
Let's see. It'll be u to the 5 halves, right? It becomes u to the 7 half. Is that right? Because we're adding 1 each time.
Right.
7 halves, and then you do the antiderivative. Let's stop here. We're good. Let's stop here. We'll finish off this problem. If you guys can try to finish off this problem, and then if you guys can start on homework, if you haven't started on 5.3, 5.4, and then do a little bit of 5.5, we'll try to catch up. We'll try to catch up with this on Friday.
Do you guys know if we have student council today? Because we did not have it